Hi, and welcome to Module 2 of this Pluralsight course titled Practical MVVM. I'm still Gilles Kleren and you can contact me on Twitter via @GillesKleren. In this second module, we will build the foundation for our MVVM knowledge. The MVVM pattern is itself based heavily on the data binding features of the XAML language. Learning about these features is therefore very important in order to grasp all that comes in the next modules. So let's start by taking a look at the agenda for this module. We will kick off the module by looking at the concept of data binding. If you're still unclear about what data binding is, all your questions will be solved in this very first part. You'll soon learn that data binding can be used to link objects to UI elements. The data binding engine is capable of binding single objects as well as collections. We will first explore the way that we can bind single objects to our UI elements. Next, we will learn how we can bind collections. Many applications somehow visualize lists or collections of data, and we will take a look at how we can link these to our UI objects, again using, of course, data binding statements. You'll soon understand that with data binding, it becomes much easier to write code for interfaces where we need to display a lot of data. This can be extremely helpful in places where data is often changing and we need to write a lot of boilerplate code that updates all fields in the UI. With the built-in system for change management, however, we won't need to write all this code ourselves. The data binding engine will take care of this. We will finish this chapter by looking at some options we have when using data bindings. Before we take a look at writing data bindings ourselves in our code, it's vital that you are clear on what exactly data binding is. So in other words, let's say hello data binding. If you look at the word, or should I say words, data binding, we can easily figure out the two main building blocks, data and binding. The data in data binding is all about the data properties on objects. So it has nothing to do with the data inside, for example, a database. It is very well possible that the data in these objects is the result of a database call or a service call, but when talking about data in data binding, it's all about data of objects. And this data we will be binding to properties of our controls. So in essence, data binding is an infrastructure that enables linking or binding the data of objects to properties of controls in our UI. The concept of data binding is nothing new and has already existed for quite some time. However, the model introduced in XAML is a very loosely coupled model. With the XAML data binding model, the control that we are binding doesn't have to know what object it's being bound to. Data binding is a XAML feature and it's therefore available in all XAML-based technologies. WPF was the first technology to introduce data binding, since that was the first XAML-based technology released by Microsoft. Later, Silverlight, Windows Phone and WinRT apps on Windows 8 and also on Windows 10 have all had support for data binding since their creation. Any data binding is always composed out of four important building blocks. On one hand, we have the source of the binding. This will be an object, and in this object, data is available in properties. So the source will be number 1, and the source property will be number 2. On the other hand, we have a control, so a UI control, to which we are binding our data. This control is the target of the binding. On these controls, we have a specific type of properties named dependency properties. Now, most properties on UI controls are in fact dependency properties, so we'll be able to use most of them in data binding statements. The UI control, so the target control, is number 3, and its dependency property is the target property, and that will be number 4. The most important thing to see here is that in order to function, a data binding needs to have these 4 building blocks assigned. When one is missing, the data binding won't work. Now, data can flow from the source to the target. Vice versa, data can also flow from the target to the source. This could be, for example, when the user has entered a new value in a text box in the UI. If this source object implements the correct interface, then the data binding engine will make sure that the source and the target stay in sync. Also, the data binding engine gives us a hook in the data binding process through conversions, which can happen on our data if needed. This could, for example, be a formatting happening on the string we need to display in the UI. Now that we know how a data binding works, let's see how we can actually bind a single object. In one go, we'll look at the syntax for binding single objects as well. You'll probably already understood that I love coffee. Remember that we are building an app to manage the stock of a coffee store. For now, let's assume that we are building an interface like shown here on the screen. And in this detail screen, we want to display some details about a particular coffee, such as the name, the price, the intensity, and the description. Instead of writing code like coffee name text.text equals coffee.name, we will be using data bindings here. Now, to do that, we need to create a data binding declaration. Most data bindings are created declaratively in XAML. And typically, we will have the format you see here on the screen. So we have the target control, so that's number 3. We need to specify which property we are in fact data binding, so that is number 4. Next, we are creating the data binding itself, and we can do so by creating a binding object and specify the name of the property we are binding to. And that will be number 2. Also, we can pass optionally some extra binding properties. The syntax with the curly braces you see here is called in itself a markup extension. What this means is that behind the scenes, a binding object is being instantiated and it's attached to an object in the XAML tree, but in itself it is not part of the XAML tree. So we have here number 2, number 3, number 4, but we are missing the number 1, the source of the binding. We'll come to this one in just a second. First, let's see some applied samples of data binding statements. In this line of code here, we have now a text block, and its text property is being data bound. We are binding it to the property coffee name, and we add mode equals one way to the properties of the binding. Notice that here I'm using path equals coffee name. This is the default way of writing the statement. However, if the source property is the first thing that you write in your binding statement, you can omit this, as you can see here in the last line of code. So remember that we were still missing number 1 here. We need a source for the binding. I've waited the longest with this one, since it's probably the most important one, since there are several ways to add a source for the binding. Let's first see how we can bind to objects declared in XAML itself. It is possible to instantiate just any object entirely from XAML, as you can see here in the sample code. This object is being placed in the resources of a container of the UI. For example, the window. Everything we place in the resources block typically needs to get a key, since it's internally a dictionary. Now, with this object created, we can now complete our data binding statement. In the binding, we can simply use the source property and refer to this object in XAML, using the static resource markup extension. And we need to pass also the key of the object. Now, while this works and will sometimes be used, it's not a very commonly used approach, since most of the time, objects won't be created from XAML, but instead we'll be getting objects, for example, from a service. Now, another problem we have can be seen on this slide here. For each of the controls in the grid, so the 3 text boxes, we need to specify the source. So we are basically writing the same code 3 times. Of course, duplicating code is never a good practice, we all know that. However, the 3 text boxes, they live in the same parent. They're all children of that surrounding grid here. Now, what we can do in this case is declaring or attaching the source of the data to the surrounding parent. So this means that we don't have the source declarations on the individual controls anymore, but instead we are moving the source declaration to the common parent. And in this case, we don't use the source property anymore. Instead, we are using the data context property. This property is very commonly used. We'll also come across it quite a few times when using MVVM. One more thing. Note that it's very well possible that we declare the data context on the direct parent, but we can also declare it higher in the XAML tree. So like I said, it's not very common that we declare an object in XAML and then use it as the data context. Very often, the object being the source for the binding will be coming from a service layer that perhaps in turn got the object from a repository, which downloaded data from a web service or retrieved it from a database. Where exactly the data is coming from isn't really relevant, but it's common that we will be binding the data context from code. In the sample you see here on the slide, we are instantiating an object in code. Like I just mentioned, this object could in fact be coming from a web service, and remember that. But anyway, take a look at the last line of the code here. We are setting the data context for the main grid, which is the grid containing the text boxes. This is how we can link an object to a UI control and set it as its data context. You probably know that XAML is XML, and very often objects are nested. It's very common to have a XAML tree, as you can see here on the slide. So take a look at the text box at the bottom of the screen. It's a direct child of a stack panel. This stack panel in turn is a child of its parent, which is a grid, and this grid can also still be nested. And at the very top of the hierarchy, we have a window. In other XAML technologies, it could be, for example, a page. If we have a data binding statement set on the text box, where no non-null data context has been specified, we will see something happening called XAML tree walking. WPF will look in the parent of the control if a non-null data context has been specified on the parent. If so, this one will be used as the source for the binding. If not, it will look a level higher, all the way up until it reaches the top level control. When it finds a non-null data context, it will stop going higher up in the tree. Note that if the required properties are not found on the data context, it will not search further. It stops with the very first non-null instance of the data context. Let's take a look at the first demo of this module, where we will learn how we can use data binding to bind the data of a single object to properties of UI controls. In the first demo of this module, we are going to see how we can refactor the coffee detail screen to use data binding. Now before that, let me quickly show you the structure of the solution. In this model project here, I have my class coffee. And in this class coffee, I have a number of properties like coffee ID, coffee name, price, description, in stock, and an image ID. I also have a data access layer, and in the data access layer project, I have this class called coffee repository. Now, a repository normally retrieves the data from a web service or from a database. Now, in this case, I have hard-coded the data. My coffee repository class exposes a getACoffee method, a getCoffees method, a getCoffeeById method, deleteCoffee, updateCoffee, and the private loadCoffees. And that's the one in which I hard-coded the loading of the coffees. Now the UI of the application is all in this joescoffeestore.stockmanagement.app project. In there I have a coffee data service, which is basically my business layer or my service layer towards my coffee repository class. In my coffee data service, I'm using the coffee repository to get coffee details, passing a coffee ID. I also have the ability to get all coffees, update a coffee, and delete a coffee. The actual functionality of the application is currently living in these two views with their code behind in the views folder. And that is coffee detail view and coffee overview view. We're going to focus first on the coffee detail view. The coffee detail view itself has a window at the very root. Inside we have a scroll viewer and there we have a grid. Inside of that grid I have a couple of labels. The first label here is the one called coffee name label that will be used to display the name of the coffee in a larger font at the top. And then I have a couple of text boxes here at the bottom, which as you can see are currently not using any data binding functionality. To refresh your memory, let me quickly show you what this looks like when we execute the application. So when I click on the Edit Coffee button here, this is that detail view with the label here and a couple of labels and text boxes, which, like I said, are not using any data binding functionality at this point. So let's change that. Now, how is the data currently being displayed? Well, for that, we have to take a look at the code behind. In my code behind, I have this property called selected coffee of type coffee. And then I have here the loaded event being handled, which we'll call a load data function. Now that load data function does its job, but the way that it's doing it is not something that I'm very fond of. As you can see here, we're grabbing that coffee name label and we're setting manually its content. And I'm doing exactly the same for all the text boxes. This is the way I'm currently displaying my data. This is a lot of manual, error-prone coding that, like I said, I'm not a big fan of. So what I'm going to do is I'm going to put this in comments. And actually, I can also remove the call to that load data, of course. And let's go back to the XAML first. And I'm going to data bind my label now. So I'm going to set the content to get its data from a data binding. I'm going to use a markup extension. That's why I'm opening the curly braces. And then I'm going to say, well, the content has to come from a binding. And to what property am I going to be binding here? That will be the coffee name. As you can see, IntelliSense is working here within the data binding statements, but it is not showing the properties that we want to bind on. Instead, it is showing the binding properties of the binding object itself. I'm going to do the same thing for my text boxes here. The first one was the coffee ID text box. In this case, I'm going to be data binding the text property. So text, getting its data from a data binding, and the property I'm going to be binding to will be the coffee ID property. And I'm going to do the same for all other properties. So I've now bound the description, price, and so on and so forth. Now we're missing something because, like I said in the slides, we have the target control, the target property, and the source property. Where are we getting the data from now? Well, I'm going to use the data context in this case. In my loaded event handler, I'm going to specify that the data context will be the selected coffee. So what will happen now is that all controls within my window will actually be looking for a non-null data context, doing that XAML tree walking that I've explained in the slides. I'm binding the selected coffee as the data context to the entire window. So this label here will search on itself. It doesn't find the data context. So it will look in its parent. That will be the grid. That one does not have a data context specified either. It will look in the scroll viewer, same thing. And then it will arrive here on this window. And that one has specified a data context. So it will be binding to the selected coffee.coffeeName property. Let's verify that everything still works. Select the coffee here, click on the edit button. As you can see, the label is displaying the data as well as all the text boxes. The image isn't showing yet. We'll come back to that later. Let's go back to the slides now and take a look at how we can work with collections. We've now seen how we can bind a single object. Let's shift our attention now to binding collections. Many applications have the need to display lists of data. Songs, images, contacts are typical examples of data which need to be displayed in lists. In our sample application, we'll have a list of coffees to be displayed. In code, this list of data is typically stored in a generic list of coffees or a generic collection of coffees. Using data binding, we can directly bind this list to an items control instance. An items control is the base class for all kinds of list controls that we can use in our views. Typically, binding a list or collection is one-way traffic. In other words, if the list is static and you're not interested in seeing changes of this list reflected in the UI, then using the generic list or collection will work fine. Now, if on the other hand, you would like to see updates to the collection, resulting in updates in the items control, you can use a different class, namely the observable collection of T. We will soon learn more of this class, but for now, remember that if you're data binding an observable collection to your items control, that changes to the collection, so adding or removing items, will result in the list being updated in the UI as well. When binding a collection, there are a number of important properties which take part in the data binding process. The first one is the items source property. The items source property is defined on the items control and is therefore available on all UI list controls. Using this property, we can specify which items we'll want to display in our lists. If we simply bind the data to our control using the items source property, we will only see the toString implementation of each object being used for the visualization. If we want to specify which property needs to be displayed, we can use the displayMemberPath property. Set the value to a property of the objects that you are binding to. So for example, point it to the name property of a coffee instance. We will also be discussing the next one in a couple of slides, and that is the item template. Basically, the item template allows us to define a block of XAML to visualize an item in a list. Basically, the item template allows us to define a block of XAML to visualize an item in a list. So we are overriding the default, which is just using a text block. Finally, the items panel is the container for the items in the items control. Let's take a look at the code to bind an observable collection of coffees to a list view in our UI. Our list view has been named main list view, and to bind it to our data, we are using the items source property, and we set it to the observable collection named coffee collection. So the list view is simply declared in XAML, and the name is set to main list view, as you can see in this snippet here. Now, before we look at the next demo, as promised, a word on data templates. When we would run the code from the previous slide, so without any specification whatsoever on which data the list view should be displaying, WPF would simply invoke the toString method on each instance. If this is not overridden in the coffee class, you would simply see the class name being displayed, as you can see here. If we use the displayMemberPath property and we point it to a property on our objects, we can visualize basically one property, as you can see here. Now, data templates, as mentioned, give us the ability to completely override how an item should be displayed in the UI. The template itself is a piece of XAML which is repeated for every instance in the collection. We can put whatever XAML we want in there, so for example, we can create a grid with an image and 2 text blocks. In the next demo, we will bind a list of coffees using what we have seen so far. Let's now take a look at how we can data bind the list that is displaying the coffees on the landing page. So let me start by running the application again. So the list that I'm talking about is actually an items control, a list view in this case, and that is displaying this list of coffees. Let's see how we can do that using data binding. Now currently in the XAML, I have this list view, which has a displayMemberPath property set to coffee name. That is the property that is being used to display a coffee in the list. Now let's also introduce some data binding code here. In my code behind, I'm going to introduce a list of coffees, so a generic list, and I'm going to call that list coffees. Now in this load data function, I'm going to say that the coffees list is the result of calling on my data service the getAllCoffees method. Now next, what I'm going to do is I'm going to make sure that my list is getting its items source set. So that will be the coffee list view dot items source, and I'm going to specify that that will be my coffees generic list. And if we run this now again, we're of course going to see the same result, but in this case we're already using some data binding. Now if you remember from the first demo in module 1, this wasn't a plain list showing just one string. There was actually some more data per item being shown, and that was done through the use of a data template. Let's see how we can introduce that data template here as well. We're going to go back to the XAML code. And what I'm going to specify is a data template. A data template is being specified for the item template property. So inside this data template open and close tag, I can now specify how an individual item will be shown. It shows some squiggly lines here. That is because I also have displayMemberPath currently set. I can only have one of the two being used at the same time. I will now paste in my data template, which has as its root a border with inside of it a grid. And notice that inside of this data template, I'm again using some data binding statements. Now the data context, let's say, so the data source for each of these data template instances is an individual coffee of my list. Let's run the application once more. And now as you can see, I have indeed some more data being displayed per item. Still, again, the image isn't showing yet. We'll come back to that later in this module. In the previous slides, we have already touched on the fact that data binding supports updating the UI in certain occasions. Let's take a look at what is needed to get this to work in this part I've titled Binding Modes and Change Management. Assume that we have again an instance of our beloved coffee class, and the instance initially has set the price property to 12. Using a data binding, we can get this value to display in the UI. On the binding, we can set the binding mode to one time. A one-time binding is about the most basic type of binding you can have. Using this mode, the value will go once from the source to the target. A change of this value in the source will have no effect whatsoever on the value being displayed in the UI. It is, however, possible that data binding keeps things in sync. The precondition is that our object implements a specific interface, namely the iNotifyPropertyChanged interface. When the value in the source is now changed, the UI will be updated as well. We do need to mark the binding now with mode set to one way, which indicates that all updates from the source should be pushed to the UI. Now, behind the scenes, WPF is listening for events being raised from the source object, and when this event is being raised, it will update the UI for us. If we allow the target to update the value, so for example the user enters a new value in the text box, then we probably want to register this value in the source as well. One way probably won't help us with this, considering its name. If you want to capture these values in the source object, we need to set the binding mode to two-way. Again, for this to work, we need to implement the iNotifyPropertyChanged interface on the source object. The interface that brings us all this magic and is therefore relieving us from a lot of manual coding work is actually pretty simple. The iNotifyPropertyChanged interface lives in the system component model namespace and only declares one event, named PropertyChanged. On our classes that implement this interface, we need to raise this event when the value of a property has changed. This is also the event that WPF is listening for to update the UI. Now, what if we're working with collections and we also want this automatic updating of the UI to work? A similar interface exists for working with collections, namely the iNotifyCollectionChanged interface. Initially, we can make sure that this data will be displayed in the UI. We've already covered that a couple of slides ago. If an item is now being added to the collection, then the items control in the UI will be updating automatically and will be showing this newly added or removed item. Notice that changes to individual items won't be visible because of this. For this to work, the individual items still need to implement themselves the iNotifyPropertyChanged interface. Now, in many cases, you won't be creating a collection yourself which implements the iNotifyCollectionChanged interface. Implementing this interface requires quite a lot of work. Instead, you'll mostly use the generic observable collection which comes with .NET. Now let's take a look at the next demo where we are using this change management in action. In this demo, we are going to change the application so that WPF will also update the UI when changes to the data are being made. Now, to do this, I'm going to have to make a couple of changes, and the first thing I'm going to do is I'm going to implement an interface on my coffee type. And that interface will be the iNotifyPropertyChanged interface. Now, the iNotifyPropertyChanged, when I implement it, has just one event called the PropertyChanged event. And this event I will need to raise whenever a value of a property has changed. Now, to make it a bit simpler, I'm going to implement a little method here, and I'm going to call that method raisEPropertyChanged. Which as a parameter accepts the name of the property which has changed. So what I'm going to do here is check if someone is actually listening for that PropertyChanged event. So if that is not null, and if that is not null, I'm going to raise that event. Passing in the current object and property changed event args. Passing in the property name. The next thing I now need to do is call this method when the value of one of my properties has changed. So typically I'll introduce a private field here for coffee ID. And then I'll use that private field within my property. And in the setter, of course, I'm going to set coffee ID equal to value. And I'm going to call that raise property changed, passing in coffee ID, so the name of the property. And what will now happen is that WPF will listen to changes of this coffee ID value. So in reality, we need to do this, of course, on all properties. So I'm going to paste in some code here. So I've implemented the raise property changed on a couple of properties. Let's now use that on our detail view. In my detail view, I have this extra button here now, just for demo purposes, called Change Coffee button. And in the Change Coffee button event click handler, I'm going to write some code that changes some properties of my currently selected coffee. So in here, for example, I'm going to specify that the selected coffee, its coffee name should change to, well, let's say something really expensive. And we can also then set the price to something really expensive. For example, $1,000. Now what this code does, it actually changes the object my UI is bound to. So I need to make sure that my UI is listening for these changes. So in the XAML code, I need to make a couple of small changes. So for the coffee ID, I will specify the mode to be one way. What this means is that changes from the source will be reflected in the UI. And of course, I need to do that for all properties. So for example, I also will set the mode to be one way for the coffee name label. Now do know that some controls, like the label and the text box, already have their mode set automatically to one way or two way. You can find this information on MSDN, by the way. Let's run this now. And let's go to the Edit Coffee page. And I will now change the coffee, and notice that the price has changed as well as the title of my coffee. So that was it for single objects. What about collections? I'm going to go to my coffee overview page, and I'm going to add another button here, which is going to add a coffee to my collection. It's called the Add Fake Coffee button, and in the event handler, I'm going to write some code which adds a coffee. So as you can see, I'm creating a new coffee here on the fly, and I'm adding that to that list of coffees. Let's run this very quickly. And when I click on this button, you'll notice that nothing is really happening. Adding coffees to that list was not reflected in the UI. How can we make sure that we see these changes? Well, currently, coffees is a generic list. I need to make this into an observable collection. I've now changed this to be an observable collection. The result of this is that when I add or remove items from this observable collection, automatically my UI will reflect these changes. I have one more problem here. getAllCoffees is returning a list, and coffees was an observable collection. Now, in the extensions folder here, I've created an extension method called toObservableCollection, which will simply change the list into an observable collection. So I can use this to transform my list into an observable collection. And let's run the example once more. And when I now click on the button, the changes to my list are reflected automatically in the UI because I'm using an observable collection. In the final part of this module, we'll take a look at some other options we have at our disposal to influence how the binding works. A very commonly used feature is a converter. Now, what is a converter, you may ask? As the name implies, it will be converting something from one value to another, and that's exactly what it will be doing in the case of data bindings. Assume again our coffee instance with the value of the price property set to 12. Now, what exactly is that 12? We can't simply say to the user, well, the price is 12. Would it be 12 euro? Would it be $12? By default, we can't specify this. Our converter can come in handy in this type of scenario. It gives us a hook in the data binding process. We can capture the value going from the source before it reaches the target and do something with it. We can, for example, add a currency symbol and send the combined value to the UI. We can do many more cool things like formatting dates or even convert a string into a color. The sky is the limit, and we'll see a couple of these in the next demo. Note that converters also work in two ways, just like the binding modes. Imagine that in a two-way binding mode, the value entered by the user contains a currency symbol. And the property on our class is again of type integer. We therefore need to remove the currency symbol. Well, it turns out that we can do this, again using that same converter. Technically, a converter is a class which implements the iValueConverter interface. This interface is pretty simple. It contains just two methods, convert and convertBack. The convert method will be called to transform or convert the data when going from the source to the target. So in the convert method, we would typically add the currency sign or perform formatting for date value. The convertBack method is only used when we use a two-way binding, so to convert the data flowing from the target to the source. In this method, we would then write code where we remove the currency sign again, so that the value can again be stored in an integer property. The binding class inherits from binding base, a class which contains some more interesting properties we can use on our bindings. Up first is the target null value property. This property allows us to specify a value which will be displayed when the value we are binding to evaluates to null. So in essence, the target of the binding would be null. In this case here, if origin country would be null on the object we are working with, we would see NA being displayed in the UI. Note that we could easily write a converter which does exactly the same thing. Another interesting property on the binding base is the string format property. String formatting is also something we would typically do using converters. However, the string format property allows us to specify a formatting for a value such as a date directly in the data binding statement. Finally, the fallback value property. It allows us to specify a value which will be displayed if the binding for some reason goes wrong. For example, imagine that we have a class which inherits from a base class, and assume that the inheriting class adds some properties. In a data binding scenario, it can happen that we receive either an instance of the base class or of the child class. In the case that we need to bind to a property defined only on the child class and that we have an object of the base class, the binding would typically fail and not display anything. The fallback value can be really useful here. It allows us to specify the value to be displayed in this particular case. Let us now extend our demo with the binding options we have seen here. We're now here again in the demo, and I want to solve a problem I currently have. As you can see in the list, it is simply showing 12, 14, 9, 11, but I don't know what that is. Well, that is actually the price, but there's no currency symbol in there. So I'm going to add that using a converter. I'm going to create a new folder here and call that folder converter. And inside of it, I'm going to create a new class. I'm going to call that class price converter. The goal of my converter will be adding a currency symbol in front of that price label. A converter is simply a class which implements an interface called the iValueConverter interface. The interface is pretty simple. It simply has convert and convert back. This convert method will be called automatically when going from the source to the target. So what I'm going to do here is I'm going to return the value prefixed with a currency symbol, so a $sign. There we go. Now, simply creating this converter doesn't really do anything. I also have to instantiate it and then apply it to my binding. Normally what I do is I instantiate my converters at an application level, so in the AppXAML. First, I need to make sure that the converter namespace is known within my XAML. So I'm going to use an XML namespace mapping for this. So XML NS, and I'm going to use the prefix converter, and I'm going to set that equal to my converter namespace within my code. That's this one. Now in here, I'm going to say converter, and then price converter, and instantiate one. So I'm going to use x:\key, and I'm going to give it a name, for example, local price converter. Now I still need to use this on my binding. So for example, in my coffee overview, I'm going to add it within this data template here. This is the label which displays the price. I'm going to say that the converter for this one should be coming from a static resource. It's defined inside of resources, and the name was local price converter. Let's run this again. And as you can see, the currency symbol is now being correctly displayed. Now I have another problem. The images aren't showing yet. I'm going to also fix that with another converter. To make things a bit easier for you, I've pasted in this new converter called the image converter. Based on the value, which is in fact the image ID, I'm going to create a new bitmap image, and that's what this converter is going to return. So effectively, it's going to convert an integer value into a bitmap image. You're basically not limited in what the converter can return. This converter I've also applied in the coffee overview. So in this image here, I'm now using that converter, the local image converter. And if we run the application once more, you can see that we're now correctly displaying the images as well. So converters really give us a hook in the data binding process. Let's go back to the slides. Now, what if you want to debug your data binding statements? Some XAML technologies, such as Silverlight, allow us to do exactly that by putting a breakpoint directly in the XAML code. However, others, such as WPF, do not. An often used trick here is to create a converter which simply returns the received value. I call it the do-nothing converter. Now, if it doesn't do anything, what can we use it for? Well, the converter is itself just C# code, and typically in C# code, we can put a breakpoint. Using this technique, we can take a look at what data the data binding statement is getting in. In the final demo of this module, we are going to use that do-nothing converter and see how we can debug our data binding statements. In the last demo of this module, I'm going to show you a little trick to debug your data binding statements. And we're going to use another converter for that. And this converter, I'm going to call the do-nothing converter, because it's effectively not doing anything. Let me show you. So as we've done previously, we're creating a converter, which is a class which implements the iValueConverter interface. There we go. So this value is actually the value that is coming into the converter, which is the value that we're data binding. So, and if we want to see what this value is, we can do that using this do-nothing converter. Now, to do effectively nothing, we're going to have it return the value without any change. But this is C# code, so I can put a breakpoint in here. But to use it, of course, I need to instantiate my do-nothing converter. The do-nothing converter, instantiate it, and say that that will be the local do-nothing converter. And now I can use this converter wherever I want to see what my data binding is doing. So for example, let's go to one of the views, let's say the coffee overview. And I want to, for example, see what is happening with this coffee name here inside of my template again. Let's run this now. And because it is C# and I've placed a breakpoint in there, I can effectively see what is happening with my data binding. So first, this value is Jill's homemade latte. Continue, and now I see that the value is espresso. We have reached the end of module 2. In this module, I have given you an overview of the options we have with data binding in WPF, or even better, in most XAML technologies. Using data binding, we can create data-driven applications with more ease. No longer do we need to write error-prone code to display and update values in the UI. The resulting code is much cleaner. Data binding, as mentioned, is a XAML thing. While there are subtle differences between the different XAML technologies, it works very similarly across the board. And we'll see that data binding is the enabler for MVVM, the pattern we will look at in the next module. I hope you have learned a lot, and that you'll join me in Module 3 for our exploration of the MVVM pattern. Thanks for watching.